Now, you and I certainly know rust when we see it. Just look around and you may see rusty bolts or even spotted or pitted surfaces on old vehicles as they drive down the road. Now, that's the corrosion that we can see, but it's what we can't see that's even more troubling. The fact of the matter is that corrosion occurs naturally. If materials aren't treated to resist the effects of corrosion, they will deteriorate. It's really just a simple law of physical science. But what about combating corrosion before it occurs? The general public does not give corrosion much thought until something happens which brings the topic to the forefront of the media and our minds. It's only when corrosion directly affects our lives that we worry about it. Will our brakes fail due to corrosion? Is the bridge that we're driving across safe? Or is that important bolt holding that crane high above our heads corroded and about to break? The fact is that corrosion remains a mystery to many of the important people you and I rely upon to keep our infrastructure operating. Designers and engineers don't always select materials that resist corrosion. In some instances, they even unintentionally create designs and manufacturing methods that actually promote corrosion. So, what is the answer? Well, Executive Branch and Government Accountability Office studies suggest that by investing in the prevention of corrosion, rather than waiting to treat, repair, or replace corroded materials, would reduce the annual price tag by as much as 40%. General corrosion, also known as uniform corrosion, occurs when a metal or alloy is placed into a corrosive solution. Now, the next type of corrosion we're going to look at is galvanic corrosion. And as its name implies, it is corrosion due to the galvanic action between two or more dissimilar metals, alloys, or electrically conductive nonmetals. This is one of the more common forms of corrosion in complex components because of the wide use of dissimilar metals in the design and manufacture of equipment and structures.
The combination of materials far apart in the galvanic series can result in accelerated corrosion of the less noble material. This is called galvanic corrosion. In many galvanic couples of this type, the very severe corrosion actually occurs in areas that are difficult to inspect, such as the interface of the metals. What you are now seeing in this sequence of images is what the interfaces look like when the samples are opened and the effects are viewed. The conclusion that can be reached from this is that what we cannot see may be the corrosion of most importance to actual equipment.
Crevice corrosion is localized corrosion that occurs in or adjacent to mating surfaces between two metals, or between metals and nonmetals such as gaskets. It's similar to pitting corrosion in that it's usually the result of a breakdown of a protective oxide film.
Crevice corrosion program running. Crevices can form under less aggressive conditions than pitting, and so are very dangerous. Crevices are commonly found at many interfaces between two materials that are not perfectly bonded together, such that there may be a very small gap between the two, which we call a crevice. It is within this crevice that water and other chemicals may be tightly held to create a very aggressive chemical environment.
Well, just as medical researchers have developed and continue to pursue ways to prevent or cure sickness and disease, so must we understand how to prevent or control corrosion. Our corrosion detectives have already developed many useful technologies and methods to successfully combat the corrosion menace, and their research and experience shows that, as in medicine, prevention is much more desirable and effective than treatment after that damage has occurred. Since corrosion is a natural phenomenon that is pervasive and invasive, we will never completely prevent corrosion or its effects. And while we can't prevent corrosion altogether, we need to detect it in its infancy, recognize what type of corrosion we're facing, and predict how rapidly it will propagate. We need to be able to detect and predict corrosion and its effects without damaging or destroying the structure that we're analyzing. Many innovative sensing and analysis technologies are available or under development, and other technologies and techniques are being investigated for future development. Another form of treatment widely used to inhibit corrosion, particularly in inaccessible places, is the application of corrosion prevention compounds, or CPCs. While CPCs are less permanent than paints, they are composed of organic compounds that contain inhibitors. These inhibitors are particularly important in preventing crevice corrosion. So detecting and analyzing corrosion and its effects is extremely important for maintenance and repair, system readiness, and ultimately, material safety. Corrosion wreaks havoc upon our valuable materials, equipment, and facilities unless we take positive actions to check it. We can no longer accept corrosion as a natural occurrence that should be ignored. Now that we have unraveled the mystery of corrosion and provided you with clues and insights into what it looks like, what it does, and what we can do about it, we can be more effective in our fight against it.